Welcome to REN World. For environment lab equipments follows equipments required to setting up of new environmental laboratory analytical balance pH meter COD assembly BOD incubator hot air oven Muffle Furnance conductivity meter turbidity meter spectro photometer flame photometer noise level meter RDS for PM2.5 and PM10 stack monitoring kit hot plate stirrer water bath microscope autoclave. Now individually equipment details and figures of equipments as under 1x1 based. Analytical balance. An analytical balance, or lab balance, is a class of balance designed to measure small mass in the sub-milligram range. The measuring pen of an analytical balance, 0.1 milligrams or better, is inside a transparent enclosure with doors so that dust does not collect and so any air currents in the room do not affect the balance's operation. This enclosure is often called a draft shield. The use of a mechanically vented balance safety enclosure, which has uniquely designed acrylic airfoils, allows a smooth turbulence-free airflow that prevents balance fluctuation and the measure of mass down to 1 μg without fluctuations or loss of product. Also, the sample must be at room temperature to prevent natural convection from forming air currents inside the enclosure from causing an error in reading. Single pen mechanical substitution balance maintains consistent response throughout. The useful capacity is achieved by maintaining a constant load on the balance beam, thus the fulcrum, by subtracting mass on the same side of the beam to which the sample is added. Electronic analytical scales measure the force needed to counter the mass being measured rather than using actual masses. As such, they must have calibration adjustments made to compensate for gravitational differences. They use an electromagnet to generate a force to counter the sample being measured and outputs the result by measuring the force needed to achieve balance. Such measurement device is called electromagnetic force restoration sensor. pH meter. A pH meter is a scientific instrument that measures the hydrogen ion activity in water-based solutions, indicating its acidity or basicity expressed as pH. The pH meter measures the difference in electrical potential between a pH electrode and a reference electrode, and so the pH meter is sometimes referred to as a potentiometric pH meter. The difference in electrical potential relates to the acidity or pH of the solution. The pH meter is used in many applications ranging from laboratory experimentation to quality control. COD assembly. The chemical oxygen demand, COD, is an indicative measure of the amount of oxygen that can be consumed by reactions in a measured solution. It is commonly expressed in mass of oxygen consumed over volume of solution, which in SI units is milligrams per liter, mg/L. A COD test can be used to easily quantify the amount of organics in water. The most common application of COD is in quantifying the amount of oxidizable pollutants found in surface water, e.g. lakes and rivers, or wastewater. COD is useful in terms of water quality by providing a metric to determine the effect an effluent will have on the receiving body, much like biochemical oxygen demand, BOD. BOD Incubator. Biochemical oxygen demand, BOD, is the amount of dissolved oxygen needed, i.e. demanded, by aerobic biological organisms to break down organic material present in a given water sample at certain temperature over a specific time period. The BOD value is most commonly expressed in milligrams of oxygen consumed per liter of sample during 5 days of incubation at 20 degrees Celsius and is often used as a surrogate of the degree of organic pollution of water. BOD reduction is used as a gauge of the effectiveness of wastewater treatment plants. BOD of wastewater effluents is used to indicate the short-term impact on the oxygen levels of the receiving water. BOD analysis is similar in function to chemical oxygen demand, COD, analysis, in that both measure the amount of organic compounds in water. However, COD analysis is less specific, since it measures everything that can be chemically oxidized, rather than just levels of biologically oxidized organic matter. Hot air oven. Hot air ovens are electrical devices which use dry heat to sterilize. They were originally developed by Pasteur. Generally, they use a thermostat to control the temperature. Their double-walled insulation keeps the heat in and conserves energy, the inner layer being a poor conductor and outer layer being metallic. There is also an air-filled space in between to aid insulation. An air circulating fan helps in uniform distribution of the heat. These are fitted with the adjustable wire mesh plated trays or aluminium trays and may have an on/off rocker switch, as well as indicators and controls for temperature and holding time. The capacities of these ovens vary. Power supply needs vary from country to country, depending on the voltage and frequency, hertz, used. Temperature-sensitive tapes or biological indicators using bacterial spores can be used as controls, to test for the efficacy of the device during use. Muffle Furnance. A muffle furnace or muffle oven, sometimes retort furnace in historical usage, is a furnace in which the subject material is isolated from the fuel and all of the products of combustion, including gases and flying ash. After the development of high-temperature heating elements and widespread electrification in developed countries, new muffle furnaces quickly moved to electric designs. Historically, small muffle ovens were often used for a second firing of porcelain at a relatively low temperature to fix overglaze enamels. These tend to be called muffle kilns. The pigments for most enamel colors discolored at the high temperatures required for the body and glaze of the porcelain. They were used for painted enamels on metal for the same reason. Today, a muffle furnace is, usually, a front-loading box-type oven or kiln for high-temperature applications such as fusing glass, creating enamel coatings, ceramics, and soldering and brazing articles. In ceramics, muffle kilns were typically used for relatively low temperatures, for overglaze decoration. They are also used in many research facilities, for example by chemists in order to determine what proportion of a sample is non-combustible and non-volatile, i.e., ash. Some models incorporate programmable digital controllers, allowing automatic execution of ramping, soaking, and sintering steps 3. Also, advances in materials for heating elements, such as molybdenum disilicide, can now produce working temperatures up to 1800 degrees Celsius, 3272 degrees Fahrenheit, which facilitate more sophisticated metallurgical applications. The term muffle furnace may also be used to describe another oven constructed on many of the same principles as the box-type kiln mentioned above, but takes the form of a long, wide, and thin hollow tube used in roll-to-roll manufacturing processes. Both of the above-mentioned furnaces are usually heated to desired temperatures by conduction, convection, or blackbody radiation from electrical resistance heater elements. Therefore, there is, usually, no combustion involved in the temperature control of the system, which allows for much greater control of temperature uniformity and assures isolation of the material being heated from the byproducts of fuel combustion. Conductivity meter. An electrical conductivity meter, EC meter, measures the electrical conductivity in a solution. It has multiple applications in research and engineering, with common usage in hydroponics, aquaculture, aquaponics, and freshwater systems to monitor the amount of nutrients, salts or impurities in the water. Turbidity meter. Turbidity is the cloudiness or haziness of a fluid caused by large numbers of individual particles that are generally invisible to the naked eye, similar to smoke in air. The measurement of turbidity is a key test of water quality. Fluids can contain suspended solid matter consisting of particles of many different sizes. While some suspended material will be large enough and heavy enough to settle rapidly to the bottom of the container if a liquid sample is left to stand, the settable solids, very small particles will settle only very slowly or not at all if the sample is regularly agitated or the particles are colloidal. These small solid particles cause the liquid to appear turbid. Turbidity, or haze, is also applied to transparent solids such as glass or plastic. In plastic production, haze is defined as the percentage of light that is deflected more than 2.5 degrees from the incoming light direction. Spectrophotometer. Spectrophotometry is the quantitative measurement of the reflection or transmission properties of a material as a function of wavelength. It is more specific than the general term electromagnetic spectroscopy in that spectrophotometry deals with visible light, near ultraviolet, and near infrared, but does not cover time-resolved spectroscopic techniques. Flame photometer. Photoelectric flame photometer is a device used in inorganic chemical analysis to determine the concentration of certain metal ions, among them sodium, potassium, lithium, and calcium. Group 1 and Group 2 metals are quite sensitive to flame photometry due to their low excitation energies. In principle, it is a controlled flame test with the intensity of the flame color quantified by photoelectric circuitry. The intensity of the color will depend on the energy that had been absorbed by the atoms that was sufficient to vaporize them. The sample is introduced to the flame at a constant rate. Filters select which colors the photometer detects and exclude the influence of other ions. Before use, the device requires calibration with a series of standard solutions of the ion to be tested. Flame photometry is crude but cheap compared to flame emission spectroscopy or ICPAES, where the emitted light is analyzed with a monochromator. Its status is similar to that of the colorimeter, which uses filters, compared to the spectrophotometer, which uses a monochromator. It also has the range of metals that could be analyzed, and the limit of detection are also considered. Noise level meter. Sound level meter is used for acoustic, sound that travels through air, measurements. It is commonly a handheld instrument with a microphone. The best type of microphone for sound level meters is the condenser microphone 1, which combines precision with stability and reliability. The diaphragm of the microphone responds to changes in air pressure caused by sound waves. That is why the instrument is sometimes referred to as a sound pressure level, SPL, meter. This movement of the diaphragm, i.e. the sound pressure deviation, Pascal Pa, is converted into an electrical signal, volts V. While describing sound in terms of sound pressure, Pascal, is possible, a logarithmic conversion is usually applied and the sound pressure level is stated instead, with 0 dB SPL equal to 20 micropascals. A microphone is distinguishable by the voltage value produced when a known, constant sound pressure is applied. This is known as the microphone sensitivity. The instrument needs to know the sensitivity of the particular microphone being used. Using this information, the instrument is able to accurately convert the electrical signal back to a sound pressure, and display the resulting sound pressure level, decibels dB SPL. Sound level meters are commonly used in noise pollution studies for the quantification of different kinds of noise, especially for industrial, environmental, mining and aircraft noise. The current international standard that specifies sound level meter functionality and performances is the IEC 61672-1:2013. However, the reading from a sound level meter does not correlate well to human perceived loudness, which is better measured by a loudness meter. Specific loudness is a compressive nonlinearity and varies at certain levels and at certain frequencies. These metrics can also be calculated in a number of different ways. The world's first handheld and transistorized sound level meter was released in 1960, and developed by Brule and Cager. RDS for PM2.5 and PM10. The respirable dust sampler is meant for monitoring the total suspended particles, TSP, in ambient air conditions. It also simultaneously used for sampling the pollutant gases like SO2, NOx, Cl2H2S, and CS2. The sampler draws the air with the help of high flow rate blower at a nominal flow rate of 1. Stack monitoring kit. Stack emission monitoring is often referred to the air monitoring of an emission point. Typically, such monitoring is carried out on boiler stacks, exhausts from printers, discharges from bag filters, thermal oxidizers, and is performed on a regular basis. Hot plate. Hot plate is a portable self-contained tabletop small appliance cooktop that features one or more electric heating elements or gas burners. A hot plate can be used as a standalone appliance, but is often used as a substitute for one of the burners from an oven range or a kitchen stove. Hot plates are often used for food preparation, generally in locations where a full kitchen stove would not be convenient or practical. A hot plate can have a flat surface or round surface. Hot plates can be used for traveling or in areas without electricity. Stirrer. A magnetic stirrer or magnetic mixer is a laboratory device that employs a rotating magnetic field to cause a stir bar, or flea, immersed in a liquid to spin very quickly, thus stirring it. The rotating field may be created either by a rotating magnet or a set of stationary electromagnets, placed beneath the vessel with the liquid. Water bath. A water bath is laboratory equipment made from a container filled with heated water. It is used to incubate samples in water at a constant temperature over a long period of time. Most water baths have a digital or an analog interface to allow users to set a desired temperature, but some water baths have their temperature controlled by a current passing through a reader. Utilizations include warming of reagents, melting of substrates, or incubation of cell cultures. It is also used to enable certain chemical reactions to occur at high temperature. Water bath is a preferred heat source for heating flammable chemicals instead of an open flame to prevent ignition. Different types of water baths are used depending on application. For all water baths, it can be used up to 99.9 degrees C23 when temperature is above 100 degrees Celsius. Alternative methods such as oil bath, silicone bath, or sand bath may be used. Microscope. A microscope, from the ancient Greek, mu iota kaparo, mikros, small, and sigma kappa omicron pi epsilon nu, scopian, to look or see, is an instrument used to see objects that are too small to be seen by the naked eye. Microscopy is the science of investigating small objects and structures using such an instrument. Microscopic means invisible to the eye unless aided by a microscope. Autoclave. An autoclave is a machine used to carry out industrial and scientific processes requiring elevated temperature and pressure in relation to ambient pressure/temperature. Autoclaves are used in medical applications to perform sterilization and in the chemical industry to cure coatings and vulcanize rubber and for hydrothermal synthesis. Industrial autoclaves are used in industrial applications, especially in the manufacturing of composites. Welcome to REN World. For environment lab equipments follows equipments required to setting up of new